Hello. Back at it. You can look at this train. Seeing if we can make it perform a little bit better. All right. So, let's see, our frame rate's pretty good here. We're at 100. But once we get the train going, it drops significantly. And then it gets back up to about 60. The fact that it's at 100 here, even though we have all the benches and all the lights active, makes me think it's not really those that's causing the issue. Let's see here. So if we say if we change the seats to being not visible, hidden in game, let's see if that does anything. No. What if we turn on the lights? If we make those not visible and hidden in game. Doesn't really change anything. So that tells me that has something to do with the logic of moving the train. And right now that logic is set up through a timeline. And it's possible that that timeline is killing the frame rate. So let's take a look at that. Um, what I could do is I could just start this. I could just start it from here and run this on tick. The game is taking place on the train. The train is already starting when the game starts in my mind, so there will not be a need to go and trigger it. The train can just start right off the bat. So let's see what happens if we remove this timeline and we just run this on tick. Let's see what happens. What's this do again? Um, so anyways, let's just keep this where the way it was set up. And we'll just remove this. And we'll remove that. And get this distance here. So hold on, let's just do event tick. sure we need this delay. So in the speed needs to be 20. On all of these. Hello, how we all doing today? Right. What's your favorite train media? What's your favorite? Are there any train games that I'm not aware of that take place on a train? All right. Let's see what happens. So it doesn't really help performance at all. So what is it about this logic that drops the frame rate in half when it starts running? Oh. Everything's running, all the trains are moving. Well, that's good. What happens if we reduce the speed? Not a dang thing. The problem is 60 is basically like 60 is fine, but good luck adding anything now. Like if we add something to this game, it's going to drop us below 60. We like what's going on in this level? Here. Level visuals. Experimental height fog. Hidden in game. Oh, it makes it worse. That's interesting. Alright. Now there's a way. Unreal Insights. Someone gave us a talk on this a while ago. let's take a look at this.
As of Unreal 5.3, Unreal Insights is officially Unreal Engine's recommended profiler. So in this video, I'll show you all the basics of getting started with Unreal Insights. I'll give you a general rundown of how Unreal Insights works, then I'll show you 2 different ways you can record traces, and finally, I'll give you a tour of Unreal Insights. Unreal Insights is a profiling tool in Unreal Engine that builds an interactive visualization of all the events that take place during your game's runtime. It lets you record sections of your gameplay and builds the visualization based on these recordings. One of these recordings is called a trace, and it stores the timing of all the trace events that take place in your game's code. Trace events are defined using macros in C++, and they measure the execution time of all the code within a scope. Unreal Insights uses this data to show you the order and duration of every trace event. Each event is shown as a rectangle where the width represents the time it took to execute. When an event is shown underneath another, it means that its scope was nested within the event above it. This nested event structure lets you see your game's performance on a per frame basis, but also lets you drill down to see every individual event that happens during your frame. To access Unreal Insights, you can use the Trace widget at the bottom of the editor. Here you'll find all the options and settings related to Unreal Insights. At the top, the Channels dropdown lets you customize the type of events that will be included in your recording. You can turn different channels on and off depending on what information you're interested in. I'll leave a link in the description to a list of what each channel does. Below it, you'll find the Stat Named Events checkbox, which lets you turn on named events. With named events enabled, your traces will be much more detailed at the cost of a slight performance hit while recording. I recommend you keep this option enabled, especially when you're first learning Unreal Insights. Next, the Trace Destination section lets you select where your traces will be saved to. The 2 options you have are Trace Store and File. The Trace Store is a shared storage location for traces across all your different Unreal Engine projects. It's also where traces will be saved when they're sent to your PC from other devices. But more on that later. Your other option is File, which saves your trace in the local profiling directory of your game. You can quickly access both of these folders using these shortcuts on the Trace widget. For now, just leave the trace destination to the Trace Store. To record a trace, you can use this button beside the Trace widget, which will turn red once you start recording. To stop
Named events, channels. All right. Those. So that's about 6 frames per second. It's gonna
recording, you can just press the same button again. To see your trace, you can select the Unreal Insights Sessions Browser option. This will open up a list of all the traces in your trace store. From here, you can double-click a trace.
Wait, what did I say?
To see your trace, you can select the Unreal Insights Sessions
Okay.
Browser option. This will open up a list of all the traces in your trace store. From here, you can double-click a trace to open it. With that, you should be able to see your first recording. Now, before I talk about the Unreal Insights viewer, I also want to show you how to record traces using console commands. This is important because you might want to record traces on packaged builds to get more reliable profiling data. In that case, you won't have access to the editor and the trace widget. To start recording a trace using console commands, you can either use the command trace.file or trace.send. The trace.file command will save your trace to your game's profiling directory, while trace.send will send the trace to your trace store. Choosing between these 2 is like selecting one of the trace destination options in the trace widget. To use trace.file, you need to provide two arguments, which are the path and the channel set. The path argument is where the trace will be stored within the profiling directory. You can organize your traces into folders this way, but just a file name will work too. The channel set is a list of all the channels you want to include in your recording, separated by a comma. This channel set is the equivalent to turning different channels on and off in the trace widget. Your other option is trace.send. This command also uses a channel set as its second parameter, but instead of the first parameter being the path, it's replaced by the host parameter. This will be the network IP address of the device that you want to send the trace to. If you're only ever recording traces on your PC, this can always be localhost. But if you ever want to record traces on other devices, then this will need to be your PC's network IP address. That way, any trace you record on the other device will be sent back to
We're
your
gonna
trace
check
store.
out this video.
Just
Go
keep in
here.
mind that setting up this connection might require some extra steps depending on your device. And finally, the last two commands you'll need to know are trace.stop, which will stop a recording, and stat named events, which will toggle named events just like in the trace widget. To use all these commands, you can open up the console using the backquote key while playing, or you can hook up each command to an input event. That way you don't need to type the command every time you want to record a trace. Now let's take a look at the Unreal Insights viewer. The timing view is the main window where you'll be able to see a visualization of all the events of the recording. You can zoom in with the scroll wheel and right-click to pan the view. In this view, you can also scroll while holding Shift to go up and down to see all the different tracks in the recording. You can see a list of all these tracks using the All Tracks dropdown, which also lets you toggle them on and off. Now let's take a look at the game thread.
Yeah.
The structure of the graph lets you see the timing of your frame as a whole, but also lets you zoom in to see the details of every small event. For example, you can zoom into the character movement component to see all the events that happen during a tick. You can see that the first half of perform movement is spent moving the character capsule and finding the floor beneath it, while the second half is spent updating the transforms of the skeletal mesh and the camera. You
How do
can
you-
look with this amount of detail into every other functionality
I guess how do we identify problematic events?
of your game, which is what makes Unreal Insights so useful. Moving on, the frames view is where you can see a summary of the frame time across the entire recording.
All right.
It's useful for navigating through your frames since you can click on a frame spike and it will be highlighted in the timing view. When you have a section of time highlighted like this, the timer and counter views will show you aggregate statistics of the highlighted sections. This way you can see which events are taking the most time within your selection. If you click on an event within a highlighted section, the callers and callees section will show you all the events above and below the event that you've selected. So if we select the physics walking event, we can see a list of all the events that physics walking calls and the events that call physics walking. Finally, the logs view shows you all the logs that happened during runtime. If you click on a single log, it will jump to the point in time when it happened in the timing view. All of these sections can be toggled on and off with these buttons at the top of the screen. Alright, so that's it for this video. If you found it useful, consider leaving
All right. Yeah, looks like we have some spikes. Uh, this it's gonna be like a learning curve to figure out what's going on here exactly. Anti-aliasing. Anyone have an idea of what we're looking at? Already messed up. What was that counter type? So what's this? Man, I don't know how to read this. Huh. Foreground worker. It's a wait for task. Let's see here. Take a look at this one. New makes games. Apparently I can't load this video.
Welcome, friends. I'm New. All game projects have to deal with performance issues. Budgets get blown, frame targets are missed, and FPS tanks. Today's video has two parts. First, we're going to look at Unreal's main profiling tool. Unreal Insights is super powerful. I'll show you how it works, and I'll teach you how to diagnose and fix perf problems in your game. Second, we're going to look at a real-world example. I've got a nasty perf bottleneck in my time rewinding project. Why is my game running at 20 frames per second? We're going to profile it to find out, and then we're going to fix it. Let's get started. Unreal Insights and tracing functionality now live down in the bottom right of the editor. If you're in an older version of the engine, you'll need to look around in the Tools menu. To launch Unreal Insights, we click on Trace and then go to Unreal Insights Session Browser. This will pull up the session browser, which shows all of the traces that we've captured. If we've never captured a trace, it's completely empty. To capture a trace, we click the button next to the trace menu to start tracing. That will turn red, which shows us that we're tracing. And if we look at the session browser, we now see that we have an entry, its status is live, and the file size is rapidly increasing. I'm going to go ahead and stop tracing before I look at my actual trace file. With that done, we can double click on the entry, and this will launch Unreal Insights. The Insights application shows us a ton of performance information across a bunch of different panes, and we will go through everything, but we're mostly going to be looking at this timeline view, or this timing view here in the center. Within the timing pane, you can zoom in and out by using the mouse wheel, and you'll notice right away that my editor has been running for quite a while because I went and got lunch and left it up. You can pan left and right by clicking and dragging, and you can zoom back in by scrolling in. Within this view, we have a bunch of different tracks. So at the top here, I have a GPU track. I have a track for my game thread, track for the RHI thread, the render thread, a bunch of worker threads, basically every thread that is running in my editor process. And For each track, we have a flame graph. So if you've never used a flame graph before, it basically goes top to bottom. And we can look here at the top and we can say, okay, we have a frame on the game thread. Within that frame, we ticked the world, we drew the viewport, slate ticked. That slate tick called slate draw windows, which turns around and called slate pre-pass, so on and so forth. So we can basically drill into a bunch of deeper calls. And as long as those calls are instrumented,
I don't know why only certain ones are highlighted right now. What I did. See here. Maybe because I double clicked on it. Okay, so this is GPU, game thread. Foreground worker. Okay.
we can see what they were doing and how much time they spent. In this top pane, we have timings for all of the different frames in our capture. The bigger the bar, the longer the frame. So if I wanted to look at this one fat frame, I can see it took 52.5 milliseconds, which is about 19 frames per second. I can left click on that to jump to it. And then if I press the F key, it's going to focus my timeline view to look at that 19 frames per second. I can left click on that to jump to it. And then if I press the F key, it's going to focus my timeline view to look at that frame specifically. So here I can see I actually spent 26 milliseconds pumping Windows messages. This is probably, well, I don't know what was going on there. I would need to drill in, but this is a really long frame. Along the top view of timing, we have a timeline, which is the time since the process started. We have a bunch of drop downs, which allow us to turn tracks on and off. So
Okay, so this is the time. This is interesting.
if for some reason I didn't want to look at, say, the game thread, I can just turn that off and turn it back on. Note, for something to show up in this list, I have to be capturing it. And we'll talk about how you configure what you're capturing a little bit later. The CPU, GPU menu also gives you groupings to filter. So if I want to turn off all the background workers, I can make them disappear like that. Other has some additional things that we can look at. Plugins has some other special things as well. But basically, this is just allowing us to turn things on and off for filtering. Another hotkey that is super useful is you can tap C to toggle between full view and compact view. So if I wanted to get a compact picture of everything that was going on, I can tap C and you can look for basically big chunks of color that might be interesting to drill into. And to go back to the full view, we just tap C again. In addition to the timing view, down at the bottom here, we have a view of logs and any important events. And if we double click, it will take us to that position in the timeline so that we can drill in. Over on the right, we have counters and timers. I find timers are generally the most useful. If I want to look at what happened in a frame, I can click on any of the tracks in my flame graph. That will select it in the timer view. I can look at inclusive and exclusive time, and I can also get a full picture of who called whatever my selection is. So that's callers. We can see here that engine loop tick called frame, which called slate tick, which called slate draw windows, which called slate prepass. And I can also look at callees, which is everything that the thing I have selected calls. In this case, slate prepass has widget invalidate called 14 times, but these timings are all tiny, 4.5 microseconds. So there's a whole bunch of stuff going on in slate prepass that isn't instrumented. And if I wanted to investigate this, what I would begin doing is instrumenting that code path and seeing the details of what is going on.
So we got our timer. Post processing. Is this I don't know what US.
A couple other cool things that we can do here. I can take a snapshot. There is a continuous running buffer in the editor, and when we click this button, it will snap that buffer and create a trace just with those details. So this is useful if, like, let's say I'm playing the game, I have a big perf hitch, but I wasn't actively tracing. I can take a snapshot to see what was there and then, you know, open it up just like our first trace, and we could see what was going on. Few other things. Tracing, there's a whole bunch of different channels that we can choose what we want to look at. Right now, I am using the defaults, so CPU, GPU, some regions, bookmarks, some other things. While a trace is running, we can capture bookmarks and screenshots, which I'll show you. So first, let me do a bookmark, which I can do from this menu, and I can also do a screenshot from this menu or press Control plus F9. I'm going to stop my trace. I'm going to come back to the session browser. We're going to look at our most recent trace. And on this timeline view, once we get back to where we were, you will see, hey, there's a bookmark here with a timestamp, and that will also show up in our log view here. So that was when I pressed that bookmark button, and that gives me a clear visual indicator of what was going on there. I also have the screenshot right here on this timeline. So cool. If I hit a bug or a performance issue and I wanted to take a screenshot so that I could remember what was going on at that point in time, we can do that with Control plus F9 while tracing. And similarly, that is also down here in our log view. So this allows us to really explore and get a full view of what Unreal was doing. And we can look retroactively, we can make changes, we can measure things over time. Other things that are useful to know. Running in the editor, we have a whole bunch of stuff running that is not our game. If we want really representative perf of just what our game is doing, we can either build, cook, and package, and then run Unreal Insights against that, or we can run against standalone mode. In both cases, what we need to do is pass an additional argument as a command line parameter. The structure of that command line argument, I believe, is -trace equals default for what I was capturing before, but you can also provide a comma separated list of arguments like CPU, GPU for the individual tracks that we want to capture. So I'm going to try trace equals default, and then I am going to switch this to standalone game. We're going to run that, and with any luck, we should see that session pop up, and we do. So right here, I've got Unreal Insights running. I also have the game coming up. My game is now up. I've lost my mouse. But you can see as the game runs, we are capturing a trace just like we did in that we want to capture. So I was capturing line parameter. It's against that. Or
settings. Additional launch parameters.
Or we can run against standalone mode. In both cases, what we need to do is pass an additional argument as a command line parameter. The structure of that command line argument, I believe, is -trace equals default for
Trace equals default. Okay. Let's go standalone. Wonder how you bookmark here. So how do I stop it? Maybe I just close it. Do you have the date on this? You know, I can look at the name on the to see. I don't know which one's which, just for sure. So let's see here. All right, it's dash 152009. All right. Okay. Close that. Does it stop eventually? Oh, okay, it does just stop. Okay. All right.
what I was capturing before, but you can also provide a comma separated list of arguments like CPU, GPU for the individual tracks that we want to capture. So I'm going to try trace equals default, and then I am going to switch this to standalone game. We're going to run that, and with any luck, we should see that session pop up, and we do. So right here, I've got Unreal Insights running. I also have the game coming up. My game is now up. I've lost my mouse. But you can see as the game runs, we are capturing a trace just like we did in the editor. But now it is just my game running. It is not any of the editor because we launched in standalone mode. So that is pretty cool. When we close the game, we will see the trace stop. Now let's look at a real world example. I've been prototyping a game with time rewinding mechanics. The way this works is each actor has a component that keeps track of its transforms and other state over time. When I rewind time, I simply play that state back in reverse. If you're interested in the full details, I have a whole video on it, but that's the gist of what's going on. I also built a debug visualization feature that allows me to see all of that state. Unfortunately, when I turn it on and a bunch of state has accrued, my frame rate absolutely tanks. I'm really abusing the debug drawing API. When I was looking at fixing this issue, I was actually really surprised about why it's slow. So it's a great example of why profiling is important. To figure out what's going on, I started by instrumenting my code. I added bookmarks, which again gives that little text visualization in the timeline view of Unreal Insights, and by adding CPU profiler scopes, which will show up on my flame graph. So I've got a bookmark for every time I turn my snapshot visualization on and off, which is that debug feature. And I've also got a bookmark whenever I begin or end a rewind. I've also gone through and instrumented all of the individual functions in my component so I can confirm that I understand why things are slow. I was expecting the slowest part to be in debug draw snapshots because what we're doing is we're going through all of that state that we've captured. We're calling draw debug point over and over and over every frame, and draw debug line, connecting all of those points over and over every frame. Here is what the profile actually looks like. Exactly as we expected, the moment we turn on the debug visualization, our frame rate tanks. The density of the work that's happening in our flame graph goes way down. And on our frame timings, we can see that we go from running around 200 frames per second to dropping all the way down to 10 frames per second. If I select one of these frames and press F, we can drill in and see what.
Well, that's actually nice because we could see that on standalone, it's actually not down to 60. It's anywhere from like, I don't know, looks like an average of about 70. So that does give us more to work with. We do have a spike here though.
What's going on? The total time on the game thread is about 110 milliseconds. Interestingly, most of that time is spent here in game thread wait for tasks, about 90 milliseconds of that 110 milliseconds. The rest of the time is being spent ticking our rewind components and calling debug draw snapshots, which is what we expected to be slow. Some of these calls are up to 2 milliseconds for a single actor. This would be completely unacceptable in a real game. But the 14 milliseconds we spent ticking does not explain why is the frame 110 milliseconds long. My original intuition was I'm going to come into debug draw snapshots. I'm going to, kick the can down the road a little bit, not really optimize this very hard, use the lifetime properties on those APIs to make less calls every frame. But this is a pretty good hint that that's not going to work. And the reason that's not going to work is the way debug draw point and debug draw line actually work is they write down some state, and that state actually gets consumed as part of rendering work. And in fact, if we scroll down and look at other threads, we can see that background worker number 14 in this case is where all that work is happening. 94 milliseconds of that 110 millisecond frame is happening on a background thread. If I shift to the compact view and zoom out a little bit, what we will see is there are these big blocks of work happening on various background threads. And that's because the renderer is doing a bunch of background work that is moving around every single frame. But this is really what the bottleneck is that is causing our frame rate to dip so hard. Unfortunately, the details of what we are doing there is not instrumented. My next step was to go into the engine source code, add some instrumentation, rebuild from source, repoint my project on top of that. And this is probably overkill for the common case, but I really wanted to confirm that I understood what was going on here. Here's what a similar profile looks like with that instrumentation added. We can see that all of the time is spent in draw debug primitives, and underneath that we are calling some functions in fbatched elements. So drawing points, drawing thick lines. In the code, if we just scroll through, there's a RDG event for adding debug primitives that then calls into...
Watching videos like this just make me think, man, am I out of my depth here? Like, geez.
The element batcher. There is a whole bunch of logic that is running here in fbatched elements draw, and this is where all of the actual work for debug drawing is happening. So our current approach is totally doomed. I had to do something completely different. Visualization falls into... In the code, if we just scroll through, there's a RDG event for adding debug primitives that then calls into the element batcher. There is a whole bunch of logic that is running here in fbatched elements draw, and this is where all of the actual work for debug drawing is happening. So our current approach is totally doomed. I had to do something completely different. Visualization V2 Grand Reveal. Note we're running at a locked 120 frames per second. When I turn the visualization on, we remain at a locked 120 frames per second. The way I solved this performance problem is I moved off of the debug drawing pipeline entirely. I made a new rewind visualization component that derives from the instanced static mesh component. There's only one function here that is really important. It's set instances from snapshots. And I refactored my debug draw snapshots function on the rewind component to simply turn around and call set instances from snapshot on the visualization component. The way set instances from snapshots works is instead of running through all of the state snapshots and directly calling debug drawing functions, it instead runs through those snapshots, samples them, pulls out a bunch of transforms based on how much time has passed and how much movement has occurred since the last snapshot. It then does a little bit of math to adjust the rotation of those transforms so that they look at one another. It then updates all of the instance transforms on that instance static mesh component parent. At this point, all we're doing is using the standard Unreal mesh drawing pipeline, which is very good at drawing a lot of meshes. And for the mesh, I just used Unreal's modeling tools to take a torus and an arrow and make a very super dumb, simple mesh. Kind of looks like a sonic ring, but it makes me happy. Here's what the profile looks like with the new solution. The main thing to notice is that our frame rate remains completely locked at 120 FPS. We don't have a big degradation even when we turn on the timeline visualization. You can see that's happening because our bookmark is still here. If I pick an arbitrary frame and drill in, what we're going to see is that one, that frame time is way down. Total frame time now is on the order of about 9 milliseconds versus the 100 milliseconds that we saw before. And the time we spent ticking also went way down. Previously, we were
He said 9 milliseconds.
frame time now is on the order of about 9 milliseconds versus the 100 milliseconds that we saw before. Okay. And the time we spent ticking also went way down. Previously, we were ticking for about 13 milliseconds, and some of our biggest offenders in the rewind component were taking 2 milliseconds each to tick. Now they're running between about 10 and 20 microseconds on a fat one. Most of this is still in visualized timelines. If I wanted to have an absolute ton of actors, there are some pretty obvious things I could do to improve this.
I still don't really know how to read this after reading that, watching that. Looks like render, graph, execute. Take a look like what a normal one looks like versus this one. These are like microseconds though. Something to do with the meta sound though, is what I'm seeing here. Tick completion events. Hmm. 1 second here. That video was, man, that was way technical for me. Like, uh, like it's helpful, but at the same time, I still don't know how to read it. I don't even know what are these arrows. You know. See, actually, in the standalone game, it's not that bad. So maybe I don't need to worry about it too much. My goal is 60 frames per second. And on the standalone, it's at 80 right now. I think it's okay. So now I have other questions. What's it do on the standalone game? Like, because if you look at the frames per second, you know, for whatever reason, it's like about 10 to 20 frames slower on the editor. Did I Alright. Fog density, I can maybe turn that down. What happens there? Doesn't do anything. was that 0.2? So say I make this not visible, hidden in game. I take these lights and I make them not visible and hidden in game. Normally I would think that those have something to do with what's going on, because those are literally the only thing in my game right now. But maybe it has to do with the directional light too. I did see something to do with the directional light in that. Oops. Well. We're about 80, averaging about 80. Sitting down doesn't really do too much. So there we were averaging about 80. So if I turn these back on, see if it really makes a big difference. Because what I was going to do is I was going to add doors. Well, I'm still going to do that. I'm going to add doors in between the train cars. And I thought, okay, well, I'll just keep these hidden until you open the door or something like that. And then that will help me with performance. But it's like right now, it's not. The lights and the train seats aren't really hitting the performance right now. Now, what I'm surprised is, how come this didn't record last time? You know, I was wondering why that didn't happen. See, I don't know. Maybe it is it's really not that much slower. I feel like it's dipping in the 70 more than it was. Oops, I just broke the train. Separating the trains really helped. I got big fast. Every once in a while there's a big spike. Garbage collection. I don't know what that means. So what's happening every once in a while is garbage collection? Lumen? Yeah, I need to watch more videos on what exactly this stuff means. Just wait. It's whatever these are. Hmm. See, these are microseconds. That's not an issue. Whatever US is. It's not a lot, whatever it is. One second here. Someone's at the door. So I'm seeing direct lighting. So hold on here. One thing that was interesting when I actually detached this train, the frame rate shot up. So that was kind of interesting. But let's take a look at this directional lighting. If I just turn this off. If I remove the visuals of the level. Um, see here. Doesn't help this. Let's see what happens if we run without directional light or anything, the level visuals in general. That's interesting. Somehow removing that makes it worse. Maybe because it's doing more work in here. Yeah. That's why you hire people to optimize your game. Turn the intensity down. I wish my computer's kind of not that good, I guess. It takes so long to get it back into standalone. And we're off. Oh, here, I changed the intensity of these. Interesting. Didn't look like the intensity actually changed, even though I changed it from 20,000 to 5,000. So just trying to understand what all this means. So sorry if this is kind of repetitive or boring. I really don't know what I'm even looking at here. I see like this is the length of the frame, right? So you can click on a frame and then hit F to kind of focus. Well, that's like bouncing around. C. Okay, C will bring it. Okay. So this is the frame I've selected, and this is like the time it takes. So for this frame that's spiked, there's some render graph execute is taking a long time. It's waiting a lot. Maybe it's just waiting for tasks. Just over and over again while we are get assets. This is taking a long time. Okay. So you asset registry get assets. Interesting. Again, when pump messages. Hmm. So it looks like you can click on the loop and then kind of breaks it down here. Viewport draw. Hmm. Interesting. All right. This is going to take some time for me to read and really understand it. So I don't know really what I'm going to be able to achieve right now. Just staring at those graphs without watching more videos and trying to figure out what actually is going on. The good news is this frame rate is a little misleading. When you actually do the standalone, it is better by about 15 to 20 frames per second, which is nice. Shadow. Shadow only has one gas shadows. We need shadows in a game. Actually looks bad but interesting in a way. Yeah, I like this better. And really, you cut off shadows, and all it does is give you like, I don't know, 3 frames per second, if that. That's crazy to me. In some ways, it's like the exact same. That's crazy. All right, and then we looks like I turned these already back on. It's visible, hidden, right? These are visible, not hidden. So what do I want to do here? I really don't like how I have to like minimize this each time. Can I turn down the lights a little bit? They're kind of weird. Is it me or the lights are acting differently in this standalone? I feel like the standalone lights are like way brighter. Way more bright. Let's go. PCD 3D. No? Okay. I don't know why those were bright that one time. After I had. Okay. So we got about 15 to 20 frames per second we can play with. The interesting thing is I'm just really surprised that by removing these benches and lights that it doesn't affect performance at all. Take a seat. Let's think about this. Time to get up. Go back to work. Wait, what's going on up here? What's going on here? What's going on with train car 6? Everything's out of whack here. It's because I flipped it. It's using a different train. Can I? Whoa. Be able to walk in between. Okay. Can I just select all of them? There we go. See, this stuff I can do. I can move objects, that's easy. Figuring out why objects take a bunch of frame rate, don't ask me that. Don't ask me that question. Don't ask me why a standalone game has a better frame rate than the editor game. Alright, let's go take a look at that. What I want to do is now is I want to... Is that better? Much better. Alright. Now it's a little bit darker now that I turned the intensity down, and that didn't really give me any boost. What it does do is it makes the ambiance a little bit more interesting in some ways, depending on the kind of game I'm trying to work with. Alright, I want to remove that. Unlock train. I don't want that here anymore. It's breaking things anyways. Or no, undock train. Yeah, we can just... Yeah, that's what this is. Because well, I don't need to go into it. It has to do with the code I just deleted. The child classes didn't have the carriages added here, so it didn't know what was going on. So what do I want to do now? I want to create another carriage that has like a sleeping quarters. So I almost want to like duplicate I can make another child of this train car. I don't think train car 2 is being used. Yes. Could delete train car 2. Create child class. You know, actually, I need it to be... No, I can do this. I can use this. Create child class. BP sleep car. It's here. And then I can just change this. Carriage 2. And then I can just remove these seats. Or maybe I can't. You cannot delete these out of the child. Frustrating. So that's not going to be helpful. What I need to do is duplicate this. Train car. Because, well, because this is a different. That's fine. Okay. Get rid of these. Get rid of. We'll let that. The engine says it's not a problem. We'll just ignore that. All right. Get rid of this. Get rid of this. I wonder if this has anything to do with the drop in frame rate. This timer by event. No, because it wasn't running on most of them. Let's see here. Let's turn off flickering on these and see what's going on there. You got about 1 frame per second back from doing that. So I don't know if that's a huge thing. I'll just keep it back on. Flicker. Alright. I don't want all of them to flicker. Okay, so you get a sleep car. I wonder if I can edit this in modeling mode. Let's see here. It's not going to be helpful. All right. Let's see here. See if I can close this back up here. I don't think so. Wanna can you merge? Oh, why not? Push pull. That's interesting, actually. Not that I actually need to do that. Extruding doesn't really help. If I guess I could extrude it and then delete it. I don't know. Can no. Hmm. Mesh. Mesh has no holes to fill. Somehow I don't believe you. Let's see here. Mesh. Triangle select. Go with that's oh okay, okay. I can create a polygrip doing that. Triangle select by material. Create a polygroup. Set. Model polygroup edit. And I can extrude this like that. Question is, do I actually want to do that? Actually, what I want to do is I do kind of want to do that here, but I want to do something else too. I just want to extrude it just a little bit. No, not that. Why, since when is it doing that one? I was always doing that. Okay. What I wanted to do is I just wanted to bring out this a little bit, so then I could. I want to bring out a wall this way coming out. So I thought maybe if I just brought this out by just a little bit, I could. Um, so what do I do if I bevel it? What does beveling do? Cancel. Bridge. Extrude. Push, pull. Okay, that's what I want to do. That's what I'm looking for. Alright, so polygroup edit. Select this. Push, pull. And I should be able to get just a little bit out here. I can make a wall. Accept. And then polygroup edit. And now I can extrude. No, it's not ideal. Push pull. Well, I can extrude it. Cancel actions. Let's just do the bottom one. Extrude. You know, I need a reference here. So you know how much room to leave. Extrude. That should be plenty. And then extrude. It's okay. We're not really going to see this. I could cut that too. For now, we'll just go ahead and leave it like this. Accept. It's actually, yeah, that's fine. And this, I can still extrude it. Not far enough. Okay. You know, I might have brought this out a little bit too far. Cool. extrude. We will do this. Well, no, we actually should do this now. Take it to about here. All right. These will be the rooms. I'm going to accept that. Let's get my light down here. Oops. What is going on there? It's just like, oh, if that, all right. All right, so, now we can just use this to fill in the rest. Push pull. Just like that. And then extrude. Okay. So now we got like a little sleeping car here. I gotta make doors for it. So what is it? You walk in, there's like stuff here. Can you see the top of that? Man. Okay, that's fine. So how do we... What I should have done is I should have, as I was pulling this out, I should have stopped it at each room and then did what I did down here. Because now... But what I can do is I can just... I can meld this to... Let me just Control Z. Like group edit. Control Y. Cancel. Whatever. All right. Poly group edit. Push pull. And then we'll accept it. And then oh, you can do it anyway. Okay. So how big do I want these rooms? Is the question. Maybe to this window. So this window is it's like a good spot right here. And then push pull to this grid point. Okay. Like group edit. Then extrude. Okay, so that's one room. And then extrude. Go back to this too. We'll just do like that. And then push pull to there. That's a little bit big. Oh, are you serious? It just undid what I just said. Okay. Push pull. Extrude. Extrude. We got like little sleeping areas with little window. Each one has a window. So now we just gotta make a door. Could have even done this better where I could have. Hmm. Because I really don't want to use a Boolean. Let's see here. Oh, oh no, I just totally messed up here. I never changed this. I should have duplicated this mesh and then, because now those other carriages just got edited. Oh, that sucks. Also, I think I did this. I should have done this a different way, and I think I'm gonna hit Control Z. Control Z. Control Z. What I want to do is I want to use this. And I'm gonna extrude this out for the ceiling. Let's see here. And let's see here. Okay. Extrude this out to about here. And then push pull. Extrude. Need to go up to where his head is. Thing is, this is gonna really mess up, like... It's gonna be really fun to paint this mesh. The UVs are gonna be kind of jacked, but you can use mesh painter or something. This is all prototyping anyways. All right. Uh, that's just snapping and it's not going through. Yeah. All right, 1 second. I'm gonna take a break real quick here. All right. So what I was saying earlier is I forgot to change this mesh, so now all of these turned into sleeping cars, which is not great. So what I need to do, I can just delete this now. Go train. Yeah, now let's just train sleeping car. And just double check. Excuse me. Train final. Right. So I need to remake that carriage car where it has an exit on both sides. All right, so let's go ahead and do that. Perspective, front. Right. All right. Scale this. Boolean. Cancel. Needs to be bigger. All right. And we gotta put the pivot back in place. Accept. Save it. Move it. Nope. Well, actually, I will need that. Move here. This change. And then light socket 1, 2, 3. Light socket 1. Light socket 2. Light socket 3. And then bench socket. And then shift right click to copy. Shift left click to paste. No. All right. Okay. Train. Carriage. There we go. Okay. So now, go ahead and remove this one. Or actually, yes. Blueprints. Sleeping car. Port. You know, for this one, I need to add more sockets for these areas. Is the light, does this not come all the way to the top? Well, we can fix that. Let's just see what this looks like now. Right click, replace actors with sleep car. So let's see. Can we fit in this? Can we even walk in this? Oh, and then I need to mess with I need to make sure the collisions are the same. Where's the default going? Um, actually, so collision. What the heck? There we go. Okay. Okay, most of this is correct. I just need to copy this one. This is going to be kind of a pain. All right. No, wrong one. Where's the wall? All right, here we go. So, Alt and drag to bring that over. Let's make it smaller. This is going to be hard. All right. Can't really see what I'm doing here. Yep, better to do this. Not snapping, but unfortunately you can't really change the size of these that well. And I think that's going to be too big. Another thing I could do is I could just, you can put like cubes in the map. I don't know, we'll figure it out. So, that's good for now. Oh, this is the suite. This one's bigger than all the other ones. This is the room to get right here. Okay. Let's try that. So cool. No, I fell off. Game over. What's happening here? Because I never changed the collision on the new train carriage. Oh, and I didn't put a no collision on that wall. So all these walls I forgot. Okay. I have the Wicked song stuck in my head. I watched the first and second Wicked yesterday, and now I just have Unlimited stuck in my head. Or I don't know the actual name of the song, but Unlimited. All right, that's all you're gonna get. All right, not that you wanted more. Okay. There we go. Boo. Man, it's an actual good way of doing this. Like where I can see. I might think about can I fix this one? Where's it going? Part of me is like, just let it be this size. That's so bizarre. You know, I'm going to use this one. I don't know why the other one's not letting me resize it the way I want to, but I'm going to use the one that will let me resize it. Swear to God, though. I don't know why I lose my this. I only needed to come out this far. Alright. Sure, it would be nice if I could just, you know, like if there was, that'd be cool if there was something I could type in the size I would like it to be. But you know, can't can't do everything. All right. Should be good. It's okay if I don't go to the edge of this one because I got this other wall right here that's giving me collision. Really fighting me here. There we go. All right. What is going on here? Oh, because originally there was a door here. Okay. Alrighty. Alright, this is our sleeping car, at least the beginning of it. Cool. What should I do now? Is the question. Add doors? Could add doors. Deciding if I want to have opening doors or sliding doors. Like, I know most doors open, you know, on a swivel, but man, it's kind of complicated to program that because you got the door opening inward towards you, and I don't really want to deal with like, you know, programming around that. Oh, hey, well, which way am I facing the door? Is it going to open towards me? And if I do I need to step back? Otherwise, the door will just hit me. I can make the doors physical and just put them on constraints, physics constraints, but I don't really know how to. I haven't really worked too much with physical constraints. Hmm. I could create. What do you think? Swinging doors? Should I have swinging doors or sliding doors? Like you know, like the Enterprise or something. Something that just like kind of. Let's see here. Right. You know what I mean, right? Should I have a door that should I have a door that just goes like this? Or does it need to actually swing open or whatever, you know? I think sliding doors are cool. The thing is the idea is this train might have different types of trains in it. Like as you progress through the game, I think there will be like a futuristic train. Then maybe you walk through a cab and all of a sudden it's like you're in a train from like the 1800s. So I feel like eventually there will be doors that will need to swing. Maybe I should just make like a dining car. No, I think we need to have doors. I'm gonna edit this real. I'm gonna change the light sockets here. So light. Like rename these sockets. Oops. So there's like 4 rooms. 1, 2, 3, 4. Actually, might be a light socket that. Maybe like a hallway light socket too. So let's see here. Okay. Let's see here. I don't really need light sockets. Um, see here. There's no post-process volume in this level. So we can use megalights. Post-process volume. Bound. Infinite. Mega lights. Yes, please. Hardware ray tracing is not allowed. Okay. Well, if I enable ray tracing, then we're really gonna screw ourselves on the performance. Where's rendering? Let's see what hit we take when we go to enable. They like turn that off? Oh, Subar. Okay. Let's see here. Well, if you have to have hardware ray tracing to use megalights, it's not really going to be a save for performance. I'm just curious to see what happens. Does it drop down to like 30 frames per second? Oh, that's interesting. Actually, we did get some performance back. Yeah, about 10 frames per second. Almost 15 frames. Which is really bizarre because when I actually just removed the lights entirely and just disabled them, and then I turned off the directional light, didn't get any performance boost. But somehow when it could have been just, I need to restart my editor. That could be it too. Let's see here. Could have just, yeah, because even this is getting better frame rate just since I restarted. We got some frames to work with. Originally, when I had it, it was like at And the editor was at 60. Then when we put it on the standalone, we found out it was actually closer to like 80. And now, in standalone, it's up to 90 again. So that, to me, is okay. You can see the train, front of the train, depending on. Savage, take a seat. Just take a seat. If someone's sitting here, look at he stands up, it'll be like right in their face with his crotch. So yeah, I don't know. If we add tables to these, like if you want to make these into a dining cart, so you can't sit from behind. Doesn't work. You have to be at least by the side of it to be able to sit down. Cool. Very cool. Starting to feel like an actual train a little bit here. You know, I have this train sound that I really am not liking right now because it has this like jingle in the background. It's like a whirring or something. I know you know what I'm talking about. I just can't place what I want to call it. But it's like this ringing in the background. So I want to get rid of that, so it's just the track sounds. Oh, excuse me. Maybe we can take a look for free sound. Subway. You know, I might be able to. See here. Might be able to edit this to where we just get the well, it says that, but that's not where I was hearing it from. It's literally in everything. I can't. That jingle in the background is unobvious. Hold on to your ears. Here. Let's see. Alright, I like that one much better than what we were using. Thank you, Arunang Shubandari. How loud is this though? We'll figure it out. Okay. And turn it to looping. Just turn the volume down. So I need to do something to kind of doesn't sound the same. We'll call it Q. A vestibule, realistic. Let's see, if we turn this off from looping, and then we put this into loop. Can we tell it when it stops and starts looping again? Oh, that's interesting. Oh, it's because I'm not using the Q. Dir Q. This has to be a sound cue. Russian nodes. Cue. Train. Here. So yeah, you can tell when it loops. Why does it do that? question is, if you set it to just a loop, a modulator is not going to really help because it's never going to go through the modulator. Can you even print strings in here? No. Can you add? What's the difference between? I really don't think this is ever going to play other than the very beginning. Oh, whatever. That's fine for now. Okay, I think I'm going to take a break here for now. We got decently far along. We got to where we have a train car. I guess that's the biggest thing we did here. Not train car, a sleeping car. We didn't have doors yet. Another thing I'm looking at as I walk through everything, I would like a way to rotate this correctly, this little lock thing. But one thing at a time. Just take a seat and rest. Thanks for stopping by. I will probably be back later tonight.